Thank you for coming. Welcome to all. This is a session on IZBR, I'm guessing, based on the title. So transforming your batch resiliency strategy through analytics and automation. Your presenters today are Chris Walker, Rebecca Levesque, I've never actually tried to say that before, and Chris Taylor. I shall now hand over to them. Oh, sorry. Any questions, please put them in the chat. Because you're all on mute, and I will interrupt the session to ask the question on your behalf, and then we'll have another question and answers at the end. Okay, over to you, Chris.
Okay. All right. Good afternoon, everyone. My name's Chris Walker. I'm an offering manager with IBM. Hopefully I know some of you if I haven't met you before. It's good to meet you virtually. We hope for the next hour, this is going to be a really interesting topic for you. I know that a lot of people think about resiliency, and you've probably all got a lot of batch workloads out there. So we want to talk a little bit about, to get you thinking about how you're doing, how you're tying resiliency to batch today. And maybe there's some questions that might enter your head about how to better approve this process, better think about how you might be more robust in how you think about these things. So if you can move to the next slide, Rebecca. And while Rebecca's moving, I've got Rebecca and Chris here from our development partners at 21st Century Software, and they're going to be talking you through a lot of the details today. But we really want to touch on, why is resiliency important? And I know a lot of you think about that. We'll touch on, some of the things that you've probably already adopted around the IBM Z ecosystem in terms of the hardware, parallel sysplex, when you're thinking about failover and GDPS and how all that brings that back together. But we really want to focus on what you're doing in terms of your sequential batch workloads. What happens when you have a problem with that, and back and data sets need to be recovered, what jobs were running when there was a problem, and how can we make that a more robust process for you to think about. Rebecca will go into a bit of the detail to start with, and Chris will give you an actual demonstration of one of the solutions we have in this area, which is Z-Batch resiliency. And we'll, as I say, we'll be here for questions as well, so please drop them in the chat and I'll be monitoring that as we go through. So with that, I will hand it over to Rebecca to take us through the first part of the discussion today.
Thank you very much, Chris. I truly appreciate it. And yes, we will chat along the subject of resiliency. But before we get into the meat of the matter, let's talk about the case for resiliency. So many times people talk about resiliency and they say, well, it's just an insurance policy, right? But there's a real cost, whether it's direct or indirect. We really need to consider the fact there is a cost associated with resiliency and what it means. 6 common categories would be loss of revenue, loss of productivity. Think about all the technical support effort that's needed when you're restoring your environment. Compliance and regulatory fines, those are always fun. Disruption in cash flow. If you don't account for the money, you can't use the money. Or your reputation and brand. And sometimes that's actually more painful than any other, right? Because unfortunately, with the internet, it doesn't go away. When you hit Google and you hit mainframe or any kind of issues, unfortunately, company names come up, and that doesn't go away as quickly as we'd like. So when we talk about what we're doing, we're really considering loss of business, loss of credibility, and loss of customers. And the thing is, loss of customers isn't just at the time of the event. Because the reputation affected, a customer may decide to or not to go to your technology. And at the end of the day, the whole concept of IBM Z architecture since the beginning has been for the concept of zero downtime. So when we talk about that, let's talk about real numbers. This is not just insurance when you think about this. A recent survey that was done by the Information Technology Industry Council brought out how that 98% of respondents said it was $150,000 per hour. 86% of those respondents said $300,000 and 34% said $1 million. That's a lot of money and a lot of cost that's associated. So when we talk about Z and we talk about the concept of 7 nines and we talk about where we're taking ourselves, it's extremely important that we understand that it is a real cost to the business, not just it's not a cost that can't be accounted for. It is real and it affects business on a day-to-day basis. Of course, smaller customers, single server environments are less affected than larger customers with multiple servers, but the fact is it costs money. So when we talk about resiliency, let's really define it for the purpose of this presentation. We want to define it as meaning the ability to complete essential business functions and meet business SLAs with no matter what the disruption within the Z ecosystem. We don't want to compare ourselves. We want to be very focused on Z because we're very proud of Z. We know we really have a strong architecture. We know we have a strong end-to-end solution. But let's talk about it a little. Let's answer some questions. And the first one here, I just want to bring to your attention, what does the business actually require? And do you fulfill that requirement end to end? Now, a lot of customers and a lot of people within an organization understand their area. So I work in storage, I work within applications, I work within operations, and you may understand what your area and your expectations are. But what does the business require? What are those SLAs? A lot of times we talk about RTOs and RPOs, but I hate to inform you, but most C-level people, they talk about SLAs. So what's the requirement and do you actually fulfill that? So when we talk about resiliency, we're not talking about a single solution when we're talking about Z. We're really talking about everything from recovery boosts to the hardware to the analytics that pull all of the pieces of the puzzle together. We want to really look at Z from not only just an availability perspective of the hardware, but we want to be able to make sure on Z that we're talking about responsiveness. So when we talk about responsiveness, that has to include the hardware, the software, and even all of the performance pieces that allow us to pull all of it together. When we talk about that, we talk about unplanned outages. Of course, everyone talks about them, but we on Z consider planned outages. We really want to make sure that no matter what the circumstance, what is affecting you, that on Z you can be up and running. And it's not just about applications in terms of a hardware perspective. We really want to get down into the applications from how does each individual application type manage. So there's a missing piece in all of the pieces that we're showing here on the screen. Everyone's seen this slide if you've done any GDPS or different presentations, but IBM Z batch resiliency, the batch component of it all is the piece that we're going to talk about today, because that is the missing link to an end-to-end solution. So let's talk about the puzzle pieces. It starts with the Z15. Technically, if you look at the Z15, it was the piece now that has brought us into the world of 7 nines. When the Z14 came out and all of its new enhancements, we knew IBM was serious about Z. And with the Z15, we know it is even further down that path. We understand encryption everywhere is core, cloud native development, cyber resiliency, a service level of excellence that allows us to take advantage of this platform into the cloud and beyond. So extremely important that if we're going to speak to this level, because we have the Z environment to allow us to do that we also consider all the pieces around resiliency. But for a second, let's talk about what we got in the Z15 itself. With Z Boost, we're able to have GPs from subcapacity to full capacity on demand. With Zip Boost, we're able to take eligible workloads and run them on the general purpose work. So we didn't have to worry about it just being zip eligible. We could use it on anything. These allowed us to get to that 7 nines from a Z perspective. And then, of course, we have Parallel Sysplex. Parallel Sysplex allows us to maintain availability of online workloads. So we're able to take data and we are always on. And this is really important when we think about removing single points of failure. We really want to make sure that we're dynamic, have workload balancing, and have the ability for us to keep all of that different cloned images and all of the data up and able to be moved around so that you can have not only the ability to have unplanned outages and unplanned outages and balancing those workloads. But you also can consider things like poor performance and how it might hit availability, because it's not just, can I actually use the platform? Is it up and running? But remember how fast the newest generation of folks click away, right? So if you're at a bank and you're trying to do online banking, or you're looking at somebody and you're interested in looking at a new insurance company, and it takes you more than 1, 2, 3, click, they've left, right? So if there's any level of the workload that's slowed down, we can't afford it. The customer will walk away. So that's where Parallel 6-plex comes in as well, making sure that we're load balancing that work and making sure that the customer has availability. Again, resiliency, availability, we have it from going from end to end. But with all of that, and the data integrity and the serialization and all of the pieces that it does it work on batch? Unfortunately not. So DB2, IMS, they have these capabilities, but batch doesn't. And we'll talk about what we can do around batch, but please don't misunderstand when we talk about DB2 batch or IMS batch, that's separate. This is sequential batch, and we need to kind of consider that. But before we do, let's talk about GDPS. If you have GDPS, that is amazing. That's what people need. It brings you consistency and at the recovery point. It is what helps bring us to those 7 nines. It's what brings us to where we need to be, right? Without GDPS, that automated recovery procedures and being able to simplify the management and the tasks and all the things that we need to do in order to bring us up at the secondary site and have all that data availability for us, absolutely could not happen without GDPS. It's an absolute requirement, but does it solve the problem? No, and that's why the whole concept of logical corruption with things like safeguarded copy are there for us, right? So you have flash copy, you have safeguarded copy, you get those copies. Is that the end of the story? Well, we're going to have to consider some additional pieces to that, right? We're going to have to consider the fact that if you have logical corruption or different errors, yes, that will bring you to that point in time. But we're going to have surgical correction to some of it. We're going to have to take the applications into consideration. In every aspect of what we do at a hardware level, we then have to take in consideration, how do the applications work against those technologies that we're putting into place? So we're going to have to consider that throughout any technology. In order to be truly end-to-end, has to tie together all of the pieces. That's where IBM Z-Batch resiliency comes in. With Parallel 6-plex and all of the tools around DB2 and IMS and so forth, those applications have tools. GDPS brings us to the consistency point. The Z boosts give us that extra oomph we need to get up and running. But how do we actually leverage the ability to get batch back where we need it to be? So let's for a second go back to the definition that we have of batch. Of resiliency. If we really think of resiliency as the ability to complete essential business functions and meet the business SLAs, no matter what the disruption within the Z ecosystem, we can't ignore batch. It is the primary in which databases are updated. So if that is the case, it has to have the same protections as the databases. Think about it. You have tens and thousands of batch jobs that are running on a regular basis. Batch is running 24/7. It's generating reports and daily process data. It's sending account statements to the customers. It's running database utilities. It's creating the backups. It's helping with the end of month processing. It's processing the payroll. It's doing the data archiving. It's updating the databases. And these are all functions people tend to forget. And for the most part, when we think of batch, we think of it in terms of those folks take care of it. I bring data to a point in time. It's my application, and the consideration of data dependencies don't always come into the mix. We think of the technologies that work so well, like Parallel 6-plex, like GDPS, and the Z itself, and we tend to end there. But that's not going to help us in the business for the long term. We have to be able to define ourselves and go beyond the Parallel 6-plex. It's a fully automatic solution. It allows for data sharing. It allows for database managers such as IMS, DB2, and CICS to be able to have that locking of the records and being able to make sure that the data gets updated. With GDPS, it is all about being automated, absolutely. But with databases, there's log information and journal information that allow those databases to get to that point in time. Batch doesn't have that. So when we look at batch from a normal problem processing, we really need to be able to handle those problems. Remember, the business has an SLA. It doesn't care if you tell them the application is a sequential batch application. And oh, by the way, everything else doesn't really manage that. And we've been doing it manually and this way, so we're good. It wants a better solution. We have to figure out how we're going to automatically identify the jobs that were open for update. We need to understand where the backup copies are. You know, a lot of folks will say, well, I go to the scheduler, and that's great. It brings you to the job in the job step, but it doesn't take you to the data set. And the scheduler doesn't automatically give you the ability to go to the backup and restore it. It brings you to the point in time. You have had to put those processes in place in order to restore the data itself. And you don't really know if you're needlessly doing backups. You don't really understand how many copies of the exact same data set you're meeting. And if there's data consistency between disk and tape, you're probably not even aware of a fact that you might have a tape input that isn't at the secondary site, because the master catalog and all of the pieces in place don't always share that information because it's in one format out of another. And for audit purposes, how do you prove it? How do you actually know that you can prove you're recoverable? Do you test application recoverability, or do you test the actual ability from you to go from one site to another and come up on the other side and run? Our testing doesn't actually prove out that we can truly recover batch in corruption or even at an actual disaster. And unfortunately, this is batch on a bad day. And we know it. It happens. And if one of the interesting things is application awareness is absolutely hard due to the network of interdependencies, especially if the files are updated by multiple jobs and multiple applications. Yes, within your application, you have probably put process together that you do extremely well. But when you take the entire environment and all of the interdependencies, it not only affects your recoverability, but let's face it, even affects your ability to figure out what keys you give to what applications for encryption purposes. The understanding of batch is left up to key people in the organization. And then it just goes downhill from there. Understanding where all the backups are, where's that safeguarded copy that you might need because all else has failed. That is truly the answer that we're trying to solve here. Automation, identifying the resources, identifying all the inventory of the data that's associated is essential if we're going to meet the expectations that the business has. Think about it. The old way of doing it is typically it's the application owner manages the data that is being used. And for the most part, your process is pretty good if it's a single application. And if the people that have put this process in place stay and truly understand it. Actually was talking to a customer who said that the way that they've solved it is that they have the ability for people to be pegged if certain circumstances come up. Really? Your answer is people are going to get paged? That doesn't seem to be an automated way. The reality is new jobs are written and old jobs are no longer run. And files are dependent and updated by multiple applications, and understanding that in real time has to happen. With IZBR, you can generate reports to show you that each data set has been used and where the backups are. You can also can automatically schedule backups of data sets that haven't been backed up. For all the backups we make, sometimes we don't back up the right data, which is a unique concept, right? In the scheme of how all of it ties together, when and how you back up a data set matters. And so you need to get the right data at the right time and make sure you can account for it. And current processes don't always solve those problems. So just to summarize some points that we've made in the previous couple of charts. When we look at application backups, we want to make sure that we have the specific recoveries that we need have to take into account the data that we're talking about. We have to be faster, smarter, and better in ways that make it automated, where it's less intervention, where it's analytic driven. Being able to have a more automated, analytic driven means we're taking dependencies into consideration and standardize across all the applications. How many different data movers or backup methodologies do all of the applications use in your organization? Are they standardized on one? Do they have the ability to have recovery JCL from a single point no matter what they have done? Those are the pieces that mean you truly can be automated. When we talk about better, smarter, and faster, we're really talking about an inventory, analytics of all the data, all the backups. That's granular, showing you the recovery points and the interdependencies. Now, when we talk about this, our newest real-time interface with IZWS is tied directly to what we call a timeliner component. And that allows us in real time to understand the opens and closes and be able to see, and we also are tracking all of the backups for all of the different tools, whether they're DSS, FDR, whatever the homegrown tool you may use. Once the determination of the point of failure has been made, IZBR can determine the data sets are open for update, restore the most current version of that file from a panel. And that means restartability only of the necessary batch jobs, and you can move forward. And Chris Taylor will be showing this in our demo today. So I'm going to go through these next few slides because this will come with the presentation so you could kind of look at it, but Chris will be demoing it. So I'll be rather quick through this. At the end of it all, what you really just want is the ability to have the restore JCL created and done for you from the exact same panel that you get an understanding of the data set. Additionally, if you have corruption, you want to be able to roll back because you want to understand if I have a corruption that happened 2 days ago, I want to know all of the data. I want to roll back. I want to know all the jobs. I want to know all the data sets that were affected. I want to be able to restore and understand that I'm restoring the correct data based upon that. And if I have to go to the -3 generation of that backup, I should be able to do that from that same panel, right? I should be able to do it quickly and efficiently. I shouldn't have to worry about the application owners figuring that piece out. Again, Chris will be demoing that, and I'll step through the slides as they're shown here. So at this point, as you can see, IZBR is changing the dynamic of batch recovery and resiliency. And with IBM Z Resiliency end-to-end, you can see that the batch resiliency piece is tying in and completing that overarching resiliency message. So at this point, I'm going to turn it over to Chris Taylor, unless there's questions that you might have. Thank you very much, Chris. It's all yours.
Thanks, Rebecca. Let me see if I can switch us over. Hopefully everybody is seeing something that looks familiar, like an ISPF screen. Thumbs up from Chris Walker, please, if you can see. Thank you. That's good. Thank you. My name's Chris Taylor, and I'm based in California, so good morning to you all. I know it's afternoon there, but it's 7:24 in the morning here on a nice, bright, sunny day. Anyway, what I'd like to do is spend the next few minutes going through some of the features of IZBR. Rebecca's, introduced some of the concepts, so I want to actually put some of the foundation to some of the aspects that she talked about. Now, what I'd also first of all like to do is we like to use use cases to show some of the things that we're trying to achieve with this as well. So the most fundamental thing is being able to recover from a resiliency perspective. So, from a corruption, and what I'm going to do is to show you how we use our databases within IZBR. There are a number of databases. There's a backup database, there's an inventory database, and then show you how simple it can be to recover from those situations. So from our main panel, what I'm going to do first of all is I'm going to go into our inquiry and then look into our backup table. We define filters or filter on application IDs, which are based on the application table, which is built from your scheduling system. So regardless of what your scheduling system is, be it IZWS, if it's Control M, if it's CA7, for example, then we can use that as input and build our application table. Even if you were to have your own homegrown application, scheduling system, we can tie into that with some customization. I'm going to use one of my demo applications here, which is called INS app. And the inventory file, as you see it here, has a lot of different fields to it. It shows us, oh, sorry, this is the backup table, shows us the backup dates, also shows us, say, for example, since the last backup, if the data set has been changed at all, which of course is relevant when it comes to recoverability, to make sure that you are aware if the data set has changed since the last backup was taken. Now, in these various fields here, we can see the backup time and we can see the change date. We can also see the backup job that was taken, and this is that took the backup, as well as the output data set name. Now we see a device type, so that means if it's gone to disk, then you'll see 200F. If it's gone to tape, then you'll see a different device type stored there, and also the volume serial on which that backup resides, which is relevant, especially if you're backing up to, let's say, uncatalogued tape data sets. What I'm going to do here is I'm going to scroll down to one of these data sets, and I'm going to go through the restore process. From here, the JCL generator here, this is a DFSMS DSS backup. There's lots of different backups that can be taken. If there's homegrown, you can also tie in with that. Some work would be required in order to be able to customize templates to be able to generate the JCL. You can see here in examples that we have Jenna and we have IDCAM. So those are some of the examples I use. There's other products such as Favor, FDR, FDR DSF. Those are all supported in the product as well. And as I said, if you do have a homegrown utility that you're using, that can also be used as well. So I'm taking this particular JCL backup. I'm saying, okay, if the JCL already exists in this output data set, then replace it. If the JCL library didn't exist, then create it from here as well. Our clients, when they do recoveries, especially of production data, they want to test and they want to look at the data first before they go and overlay the main production data set. So what I'm going to do here is I'm going to create a new data set name, and it's saying that if this output data set is already there, then replace that as well. So if I hit enter from here, it's going to generate JCL that will be fed into a proc, which is our version for a DSS recovery. So this is, in our case, is called UDSS REST. Now, some of the other statements that you'll see down here from line 25 onwards, they're typical DSS type statements. The input tape or data set in this particular case, you can see here in this particular DD. Now, this is an SMS disk data set, so we don't really need to supply this information, although it will work. But as I mentioned previously, in the case of an uncatalogued tape data set, that would be important, so you know where it resides. Now, some of these statements you'll see here, for example, this is a GDS, and we say target GDS active. Now, that may not be something that you want to do. You may not want to put it back into the active sphere. You may want to recover it as deferred, for example, so that it doesn't compromise the sphere. You may not want to use tolerate NQ failure. This can all be edited here before you submit the job. And also, if you decide you don't want this on a permanent basis, the template can be customized in order to be able to, to remove those statements. On line 27 here, this is the replace statement. So this is replacing the output data set. That would be this p390.test.dss rest. And also then that's where it gets renamed as well. So that's the example of a DSS recovery. We'll take a quick look also at a recovery from IB Jenna. So in other words, this is where a data set's been copied to another location, effectively becoming a backup. You'll notice also here that we have a backup method called allocat. Now, what allocat is it's not something actually which you recover as such, but it is used for the recovery of these other data sets. In other words, if I do a type an R from here, we'll get the same kind of panel as we got before, but I can change the output data set here to go to, to a different member. And I'm going to also store this in a different data set name. Again, we have the replace statement. And what we get now is, instead of, because IBGenner doesn't have the attributes of the data set, we need to define them first before we write into it. So it's saying here, if this test.genrest exists, then delete it, and then use these attributes here to define the data set before I actually run the Jenner step. And again, we've got the input data set name for where the backup is, or what's considered the backup, in order to fill the data set. Now, if you, for example, as a lot of shops, they don't necessarily want to have data class, store class, management class defined in this kind of JCL, then that would be something that you could, again, remove from the template or remove from this particular instance, so that SMS will do its thing and the data set will be recovered to the correct location. I'm relying on somebody to mention if there's any questions that come up, but otherwise I'll just carry on. So that's the first use case about recoverability. The next use case is to say, okay, we'll go into the concept of what we call critical data sets and what we mean by that from an IZBR perspective. First of all, we'll look at what happens if we have missing data sets, and also look at data sets that are being backed up multiple times, because sometimes the example I like to use is with a client I worked with in the United States. They had an application job that ran, or application batch cycle that was like only about 10 jobs at the most, and it only ran for about 20 minutes. But within those 20 minutes, they backed up a particular group of data sets 6 times. So from that one run, they had 6 output data sets, which then were probably kept for a certain amount of time. And the problem is, of course, is, first of all, it might be useful to know where to recover from, but also that you're using up extra resources. Maybe that job, maybe that batch stream would have run in 10 minutes instead of 20 minutes if you hadn't been taking so many backups. So we also can, through use of IZBR, we can also monitor the kind of backups that are taken and how often they're taken. So I'll try and show you what that looks like now. So we have some reports that we run on a daily basis within the product, and I will go into that section now. So I'm going to look at the backup report now. Under normal circumstances, this backup report would be something that you take, you run this job after you've completed the backups in a daily cycle. And I purposely, for demo purposes, I put this at the beginning of the cycle so that you can see that I have data sets where the backups are not being found. So this, in a normal installation, of course, would be thousands and potentially hundreds of thousands or millions of data sets. So what we do here is we also have another report that we use, and we call that the BackWO report, or backup without. And if I show you that, then you've got an abridged version of this. And this could be something, for example, that you could maybe send to, storage administrators, application folks on a daily basis to make sure that they have the backups that they expect to have. Now, where this information is fed from is something called the backup table, and which we also just looked at, and I showed some of the various aspects of the backup table earlier. But one of the other things that we'd like to look at is the reports for, let's say, duplicate data sets that we have there. So in this particular case, this is a report that we run, and we show where a particular data set might have been backed up multiple times by different applications. And in this particular case, if you look at this IZBR demo.testing.inventory, you'll see here that within the space of about 20 minutes, this data set was backed up 4 times. Well, first of all, that may not be necessary. We could say, okay, well, let's just go with the one that took place at 2:47, and that's sufficient. And then also from a recoverability perspective, if you have to recover one of these particular applications, which is the best one that you need to go back to? Now, there is a process within IZBR called cross app. And if you activate that, what it will do is it will only back up that file 1 time. So then that would also make it, from a recoverability perspective, that would make it easier to identify which data set do I need to go back to, or which data set version. And then also to say, okay, well, I'm not using some of the extra cycles, extra storage space in backing up, this particular data set. So these backups were actually taken at, at 2:47 this morning or 2:30 this morning. And then you can see the older generations were ones that were taken earlier on, and you can see that they've changed since. That's also, if you need to go back to an older version, then also it will warn you that the data set backup version has been changed. The inventory in itself, this is tracked in our real-time SMF component. So in other words, when a change gets made, the backup table will also be updated to inform you that that has taken place. Another use case that we're encountering is, we're from an analysis perspective also, is to see in the inventory, from an encryption perspective, data set level encryption is becoming a hot topic. And what we also have is a sub feature within IZBR to be able to generate JCL that we feed then to our ZDMF product, which can enable the data sets to be encrypted and then, in compliance. Now, we need to know then which data sets are associated with a particular application. The application groups think they know all the data sets that might be associated, but often what we find when we actually go into an installation is that we see that, in fact, some data sets are being used by multiple application groups. So going back to our inquiry panel and looking at the inventory, I'm going to look at the inventory-based components, and I'm going to go to an application here called INSCT. Now in here, we have all the data sets that are associated with this particular application, and it is a small demo application that we use. So we talked earlier about the concept of critical data sets, and I'll explain what is meant by that. From a resiliency perspective, when we come to recoverability, often the data sets we often consider the data sets that are created as part of the output process. So in other words, maybe backups and those kind of data sets, but often the ones that get forgotten are the input data sets. And, so those are the ones when you get to a DR site or you try to do, bring up an alternate site, all of a sudden, you're missing a critical data set. So we have two categories of critical data sets. We have a status of 1 and a status of 2, as you're seeing here on the screen. A critical 1 data set is a data set that is used for input only. It's not written to, it's often a disposition old or disposition share, and it's used for input only. And as you can see here, part of this application, because it's using an FTP process, it's even using something outside of the application itself. It's using a TCP/IP data set. And again, we shouldn't necessarily be concerned in the sense of whether that data set should be backed up as part of the application. But of course, we need to make sure that those kind of data sets exist at the alternate side if we need to run it. The status of 2, with the exception processes you're seeing here, that is a data set that's open for input and also open for output. In other words, this is a data set that is an existing data set, but it is then being modified as part of the application cycle. So that also needs to be taken into consideration. So despite the nomenclature there, the data set status of 1 and 2, as far as the product is concerned, are both considered to be critical. The status of 3 is a data set that is deleted as the first stage of the application cycle. Those are generally ones that we don't consider so critical because usually they can be recreated, and they will be recreated as part of the daily application cycle. And then the status of 4 or non-critical are data sets which are created as part of the application cycle. And you can see there's a few GDS data sets here. So for example, if you see a file type here of C, that means it's a cluster, it's a vSAM data set. If you see P, it means a PDS or PDSE. If you see G, that means it's a generation data group or GDS. And then if you don't see anything, it means it's a normal sequential file. Some of the things that are tracked in here, we can see the data set when it was created. We can see the data set when it was last updated, as well as reference dates as well. And then over here to the right, you can see that we have some space allocation attributes or quantities. The allocation kilobytes is the current allocation kilobytes, and then you have lows and highs as well. So those are things that factor in when we come to the recovery time to be able to to be able to estimate exactly how much space is going to be required during the recovery process. And one last thing to mention, going back, we talked about encryption earlier. From a resiliency perspective, often we categorize things as critical and non-critical. But when we come to the encryption of a particular application, we need to know what data sets are part of an application. It doesn't matter if they're critical or not. From an encryption perspective, you need to make sure that all data sets are covered, because if you don't allow access to a particular data set, then the batch process may fail with a security violation, and that tends to happen in the wee hours of the morning. And that's when you have to then start getting people out of bed and start making security changes and things like that in order to make the application be able to run again. Now, one of the other things in that same vein that we talk about is that what happens if you have multiple applications referencing a particular data set or group of data sets? Well, no, that doesn't happen. But more often than not, when we go to customer sites, this is something, one of the most common laments we hear is why is that application looking at that data set? So in this particular case, what you're seeing here is that a particular data set, this IZBR-demo.testing.reports, is being accessed, in fact, by 5 different applications. And those all need to be taken into consideration and to say, okay, first of all, is that allowed? Is that something that the auditors want to see? And if the answer is no, then fix it, or to say, okay, if the answer is yes, that they are allowed to access those data sets, then especially when you come down to an encryption perspective, you need to make sure that that the applications have access to the key that will allow them access to the data sets. So this is where this comes into play when we talk about cross dependencies. And we were recently working with a customer in Brazil, and we saw something in the region of about 10, 12, 14 different applications that were referencing the same group of data sets. And it's good to draw attention to that, just in case that's a problem. Okay.
Hey, Chris, we had a question came in a few minutes ago. Going back a few minutes to what you were talking about previously, does IZBR read the DFDS backups to determine what is on the backups? And does it understand logical versus physical dumps?
Okay, yes, that's a very good question. Thank you. Actually, the way that this is implemented is that as the DSS, we have a feature within the product, as the DSS backup is being taken, that we cut SMF records that will actually reflect the individual data sets that are on a that are being taken on and successfully backed up to dumped to tape. And what under normal circumstances, all you'd see is like an output data set being created, and that would be what I refer to as the container file, the output file. But the individual data sets are being reflected, and that is what we are seeing in the backup table. It is it's not real time, but it's close. In other words, within 15 minutes or so, you're going to see it in the backup table so that you'll know how to recover. Second part of that question, that applies to both logical dump records and physical dump records. Hopefully that answers the question.
Yep, I think it does. Thank you.
Okay, thanks. Okay, going back to my use cases here. Another use case that we want to see, and all these use cases that we're showing here are things that are being used by various companies around the world, and so these are based on real life cases and how the product was used to be able to assist them. Seeing backups as well as also knowing exactly what data sets are in use is one of the next features we're going to talk about here. And also to be able to identify data that is related, that it was used, let's say, in an application cycle. So what we have here is we have a feature called Timeliner. And Timeliner is a real-time function, because this is not just reading SMF records. This is actually today, actually hooking into open and closed SVCs. So the information that you can see about when jobs start and finish it's real live stuff. It's not just SMF or Memorex, as they used to say. You'll see here, for example, there's an active state yes or active state no. Now, if a job was actually active, you'd see it yes, and you wouldn't see an end time because the job's still active. But what we can do from here is and this has been modified recently within the product to enhance the reporting capabilities to understand what is going on in the environment more. So if I drill down to this, and I can see here, for example, that, we have a couple of steps in this data set, and I'm going to do a plus next to this step, and you can see we have an input and output data set. The name of said input and output data sets, we also see which DD names we used and the valses on which the data sets now either reside or resided when they were being used. So I can actually expand the output data set here. And I can see, for example, that this IZBR demo.testing.ct1.ps was subsequently used and read in other jobs as well. So I can see it was used in CT006, 7A, 8, and then it was also used in a different application, DDA. So I can then even drill down to those particular levels and see if they were used subsequently elsewhere. So the input data set is here. And if I then go back here, you can see that if I do a selection here, I'm back at where I started. So in other words, it has the ability to go forwards and backwards to be able to narrow down exactly where data sets were subsequently used. Now, if anybody has seen any of our previous presentations on this, we had something called the Cascade Report. Now, we've enhanced that recently to do something called a forward cascade and a reverse cascade. So what I can do from this screen is on that same job INSCT004, I type in N, which means I'm going to do a forward cascade for this. And you can see then in one view all the subsequent jobs and particular steps that use some of the data sets, for example, that were created. If you see a red indication here, that means that the data set was either created, if it's an input data set, or it was subsequently used to create another output data set further on in the stream. So all the steps that pertain to this particular job are you can see here in white. And if I wanted to drill down to a particular step name and just see what's associated with that, then I could do an N from there as well to do another forward cascade. Again, we could do an input data set and we can expand all of these. For example, this is, again, we'll see the same kind of data sets that, or job names that we saw previously in the other example. Now, from here, if I just quickly go back into that, you'll see here now the times of these jobs are in ascending order, where in fact the data set was used subsequently, nearly an hour later. Now we have the capability of going backwards in this, and we use a P for previous. So in this particular case here, we have, we're going backwards in time. So in other words, we can see here that this particular job is, again, INSCT004, but we can then see if this job is used as an input data set that we can go backwards in time. So we can see here that this job was written, or this data set was written to by both INSCT003 and INSCT002. And here's the steps which were used. In this particular case, now you can see that the dates and times are in descending order. This is a very, very powerful feature, and this is going to be the basis of future enhancements within the product as well. And one of the other things we can do from this particular step is to say, okay, well, let's see if we can recover a data set from here. So we're going to use this as an R, and we can go, this links into our backup table. And from here, I can say, okay, I'm going to take the last known good backup of this data set, and I'm going to do select next to here. And then we're back where what we saw previously in the recoverability or the restore screen, to be able to then set up JCL in order to recover an individual data set in this case. That's what I had on timeline. So I've got one more thing that I want to go through and just quickly talk about the audit check, keeping an eye on the time here. We're going to go back into the reporting capability, and then we have something called the audit check. Now, the audit check, what that does, and this is something that's useful for the auditors, let me go back to my use cases as well, is that we want to be able to see, for example, if somebody is using data sets outside of the job scheduling interface. We do see customers who like to, some occasionally, and we had one recently where it seemed like they were running thousands of jobs outside the scheduling interface. I'm not quite sure why they want to do that, but also you might, one of the common uses of this would be to see maybe if you've got production data sets that are being accessed by test applications, or even ISPF users, like in the example that we're seeing here. And my user ID is P390. So we're seeing here that I'm referencing the IZWS JCL library, which is perfectly acceptable. But there may be other reasons why somebody may not be authorized to do that, unless security allows them to, or they're doing it through methods that they shouldn't be doing it. Also, there's a flag here to show you if the data set is being updated during this process. This is all highly customizable in the sense of you can say, okay, well, I'm not really interested if somebody's just using a TCP/IP data set, to read it, because that's part of their process. So you could remove that from this list as well and just home in on the really, really important ones that you want to look at. Not sure if there's any more questions, but that basically was all that I had to show today. So I will turn it back.
Yes, there is a question in the chat. There's a question. It says, is there a batch version of the forward cascade, so you could look at all of your files and see where they are used as input, output?
Yeah, yes, there is. Yes, there is. There's a batch version of the forward cascade and the reverse cascade as well. One of the other things that we've recently introduced, and this is kind of a little bit outside of the demo, but let me see if I can find it, is actually in our reports here. We have something also where we could see at a specific point in time. In other words, between the times of 22:52 yesterday and 22:53 yesterday and 40 seconds, these are all the data sets that were open at that particular point in time in the system. So that's something else that could be used as well. From a recoverability perspective, to know exactly, well, we had the outage at this particular point. How was it affected? So that's something that's very, very recent, a new report that came out, and that was run in batch as well. Hopefully that answers the question.
Yep. The response to that is fantastic. I also was quite interested in that particular cascade feature, because these days it's a little tricky to know your data flow
Right.
along with your batch scheduling. So it's something that could help people to optimize their schedules. So, all the jobs that just read a file and the jobs that actually update a file, and the orders
Right.
is quite often lost. And a lot of extra jobs get put in that maybe needn't be there in that particular flow. So I think that's
right.
quite an interesting additional use.
Yep. Yeah, we're very excited about that, and the potential that brings, for future enhancements, which we're working on right now.
Excellent. If anybody else has any questions, you've been set to be able to unmute yourself. So please feel free to unmute yourself and ask questions.
I just wanted to say I really enjoyed the presentation. Thank you.
Thank you very much. Just while if there are any other questions out there, we do have a material that we can share with you about more information on this. You can reach out to me, Chris Walker. My email is in the presentation as well. We're happy to have a follow-on discussion if that's something that is of interest to you as well.
Yeah, and do be aware of the fact that all the sessions are being recorded. So the presentation will, has it already, or will it be uploaded to the GSE website? It should be there at some point. And of course, the live demo will also have been recorded, which is nice. If there's no other questions, then I thank everybody for attending. Please click on and add your session feedback so that we have good ideas as to what to include next time, hopefully in a face-to-face session. But I think this was very interesting. And I thank Chris and Rebecca for their presentation.
Thank you very much, everyone. Have a great rest of your day.
Thank you very much, everyone.
Thanks. Bye.
Yeah, thanks so much.
Bye-bye.
Bye-bye.